Hello everyone, my name is Nidhi. I am assistant professor in Suresh School of Pharmacy, which is a part of the Suresh University, Jaipur. And today we are going to discuss the carbonyl compound. In the last few videos, we have also studied or we have also discussed this carbonyl compound. And this carbonyl compound is the fourth unit in this pharmaceutical organic chemistry. Firstly, we discuss about the objective of this today's lecture. So today's we are going to learn about the qualitative test for aldehydes and ketones. So here we are going to discuss about the qualitative test for aldehydes and ketones, and also we are going to learn about the structure and uses of compounds that are related to aldehydes and ketones. So here we are going to the studio. So here we are going to learn about the, or we will study about the this qualitative test for aldehydes and ketones, and also discuss about the structure and species of compounds that are related to aldehydes and ketones. And the student outcome is that they will going to learn, they will going to know about the what are the identification test for the aldehydes and ketones. If a sample is given to the students in the lab, then how they will identify that it is the aldehyde or it is the ketone, or separating the other functional groups or separating the other compound, means the carboxyl compounds, alcohol from them. So here, so these identification methods are very useful for the identification for identifying the aldehydes and ketones, and they will also learn about the structural uses of formaldehyde, acetone, valine, benzaldehyde, and these all are containing the functional groups that are occurring in this aldehydes and ketones. Next was to the quantitative test. So both aldehydes and ketones will react with a number of nitrogen containing compounds through nucleophilic addition and subsequent loss of water to give reaction products that have a carbon nitrogen double bond. So these aldehydes and ketones are react with a number of nitrogen containing compounds. So these aldehydes and ketones, these are reacting with the nitrogen containing compounds through a nucleophilic addition. And there is a loss of water molecule from that, and there is a reaction product, and after that there is a bond between the carbon and nitrogen. So these aldehyde and ketones are reacting with the compounds that are containing nitrogen in them. So when they are reacting with this nitrogen containing compound, and there is a nucleophilic addition, means there is an addition of nucleophile on these compounds, and plus there is a loss of water from this reaction. So from the reaction products there is a loss of water, and there is a formation of the carbon nitrogen double bond in this uh, carbon nitrogen double bond in the product that is formed from the reaction of this aldehyde and ketone, and where there is a loss of water also. So these reactions are used to distinguish between aldehydes and ketone from other functional groups. So these are the reactions that are distinguishing between these aldehyde and ketone from the other functional groups, and they cannot be used to distinguish between a ketone and aldehyde. So they are so these tests, which are the following tests that are given in this qualitative test. So they are used to distinguish the aldehyde and ketone from the other functional group or the other compounds, but they are not they cannot be used to distinguish between the ketone and the aldehyde. So the following tests that are used to identify the presence of aldehyde and ketone are your 2,4-dinitrosamine hydrogen test and the sodium bisulfite test. So here these tests which are used to identify the presence of aldehyde and ketone in them. They are the first test is a 2,4-dinitrophenyl hydrogen test, and the second is a sodium bisulfite test. So these are the two tests in which there is a reaction of the carbonyl compound and the nitrogen will occur, and there is a formation of a new bond between the carbon and the nitrogen will occur, and there is a loss of water also occur from these products. and it is also used to distinguish, these both tests are used to distinguish the aldehyde and ketone from the other functional groups, and but they are not they cannot be used to distinguish between a ketone and the aldehyde. So here it is the first test, that is your 2,4-dinitrohydrogen test. So here in this, the aldehydes and ketones are reacting with this 2,4-dinitrophenyl hydrogen, and they are giving a yellow to orange precipitate. So here you can see these in the test of this 2,4-dinitrophenyl hydrogen, these aldehyde and ketone, these aldehydes and ketone are reacting with this 2,4-dinitrophenyl hydrogen, and there is a formation of this yellow and orange precipitates are formed. So here you will see that this is a ketone, this is the aldehyde, and then aldehyde is reacting with this 2,4-dinitrophenyl hydrogen. So there is a formation of this acetaldehyde 2,4-dinitrophenyl hydrogen. So here you will see this, that there is a formation of bond between the nitrogen and the oxygen, and there is a removal of water molecule from this reaction product. So here you will see that C double bond N is formed, and this H2O is removed from here, and the C double bond N is the new bond that is formed from the reaction of these two reactants, and this is your aldehyde, and this is the nitrogen containing compound, that is your 2,4-9-dinitro. So on the second position as well on the fourth position, the nitro group is present. So and this is the hydrogen group, and so that is why its name is 2,4-dinitrophenyl hydrogen. So after the reaction of this aldehyde and ketone with this 2,4-dinitrophenyl hydrogen, we are getting a yellow to orange precipitate. The yellow to orange precipitate is formed from this aldehyde and hydrogen. There is a formation of this acetaldehyde 2,4-dinitrophenyl hydrogen. Next is your this is a ketone. So this ketone, when it is reacting with this 2,4-dinitrophenyl hydrogen, then there is a formation of this acetone 2,4-dinitrophenyl hydrogen. So in this also you will see that there is a removal of water molecule from this ketone and the aldehyde, ketone and the this nitrogen containing compound, that is a 2,4-dinitrophenyl hydrogen. There is a formation of this acetone 2,4-dinitrophenyl hydrogen. So from the hydrogen, it is the formation of the hydrogen, and they are given a yellow or orange precipitate. So this is the first test, that is the 2,4-dinitrophenyl hydrogen test, and the qualitative test of aldehyde and ketone. The aldehyde and ketone are reacting with the nitrogen, the compound that is containing a nitrogen in them, and after that there is a reaction between both of them. There is a removal of water molecule from the product and from the reaction product, and there is a formation of product, and the product of this qualitative test that forms carbon and the nitrogen double bond in one. A new bond is formed between the carbon and the nitrogen bond, and they are also, this method is also used to distinguish between the between this aldehyde and ketone from the other function group, but they cannot give test for differentiating between the aldehyde and ketone. So these phenyl hydrogen tests and the sodium bisulfite tests are not given by any other functional group. So they, in the first test, that is the 2,4-dinitro phenyl hydrogen test, in this you will see that the aldehyde and ketone are reacting with the 2,4-dinitrophenyl hydrogen, and there is the formation of a yellow or orange precipitate of a product. So the chemical reaction, that is your first is your aldehyde, and aldehyde is reacting with this 2,4-dinitrophenyl hydrogen, and there is a presence of second on the phenyl ring on the second and the fourth position. The nitro groups are present. So this 2,4-dinitrophenyl hydrogen, here the acetyl, this hydrogen, that is your NH2NH, and there is a formation of this acetaldehyde 2,4-dinitrophenyl hydrogen is formed. Next is this is your ketone, and this ketone is reacting with this 2,4-dinitrophenyl hydrogen, and there is a formation of this acetone 2,4-dinitrophenyl hydrogen. So there is a formation of this product is formed. Next is this is the sodium bisulfite test. In the sodium bisulfite test, the aldehyde and ketones are combining with the sodium bisulfite, and there is a formation of a well crystallized water soluble product that is known as aldehyde bisulfite and ketone bisulfite. So in the sodium bisulfite test, the aldehyde and ketone are combining with the sodium bisulfite, and there is a formation of well crystallized water soluble product that is known as the aldehyde bisulfite. So here the aldehyde and ketones are reacting with this sodium bisulfite, and there is a formation of a soluble product that is your aldehyde bisulfite, and the ketone bisulfite is formed. So this is the chemical reaction which is given below. And this is your aldehyde, and aldehyde is reacting with the sodium bisulfite, and this test is then giving the product that is your aldehyde bisulfite. It means that if the acetaldehyde is reacting with the sodium bisulfite, then the product that is formed is your acetaldehyde bisulfite. So this is your bisulfite, and second is your ketone. Ketone, that is your ketone is reacting with the sodium bisulfite, and by the reaction of this ketone bisulfite, there is a formation of ketone bisulfite is formed. So this is a second method that is used to distinguish this aldehyde and ketone from the other functional group. So this test is given, this both test 2,4-dinitrophenyl hydrogen and the sodium bisulfite, both of these tests are given by the only by the this aldehyde and ketone, so that we can distinguish one from the other functional groups. The tests that are given for the distinguish between the aldehyde and ketone, that is your SCIF test. So that both of the tests that are used for the distinguish of your aldehyde and ketone from their your other function group, but these are the tests that are given for the distinguish between the aldehyde and ketone. If the sample is given in the lab and we have to distinguish between them, that what is the aldehyde and what is the ketone, then we will going to give this test. These tests, SCIF test, filling test, so these are the tests that are given by the aldehyde and ketone. So first is your SCIF test. So in this SCIF test, you will see that we have to take 1 ml of aqueous or alcoholic solution of organic sample. So the organic sample that is given in the lab for the testing. So in that we have to dissolve, or we have to add 1 ml of aqueous or alcoholic solution, and in that we have to add 2 ml of SCIF reagent. So in that organic sample in which we have added 1 ml, in which we have added already the aqueous or the alcoholic solution we have made, and in that organic sample we have to add our SCIF reagent, and in that SCIF reagent we have to that shake well, and this 1 ml, 2 ml of the SCIF reagent is added, and we have to shake that test tube, and after that we have to we will see that there is a deep red or violet color shows presence of aldehyde group. So the addition of the 6 reagent in that aqueous or the alcoholic solution of organic sample, we are getting here a red or the violet color, and that is showing the presence of this aldehyde group, and this means that there is. So in this test, what we are getting, this test is for your aldehyde test. or your aldehyde group that is present in the compound. And in this test, we should never heat during this test. There should be no heat during this test. And second is your failing test. So in your failing test, failing solution, which is a complex compound of copper. So this failing solution contains a complex compound of the copper, and when aldehyde compound is treated with failing solution, then this copper, which is around 2 plus, is reduced to copper plus 1, and the aldehyde is reduced to your acid, and during the reaction, a red precipitate is formed. So here you will see that the failing solution, which is a compound that is containing a complex failing solution, which is a complex compound of the copper, and then this aldehyde group, and when this aldehydic compound is treated, when this aldehyde compound is treated with your filling solution, when this aldehyde compound is treated with the filling solution, this copper is reduced to copper plus. So this copper 2 plus is reduced to copper plus 1, and the aldehyde is reduced to acid. So these aldehyde is reduced to acid when this filling solution is added to an aldehydic compound, and during this reaction, during this process, a red precipitate is formed. So in the sketch reagent, there is a presence of this deep red or violet color, which shows the presence of the aldehydic group. But in case of this filling solution, there is a presence of this red precipitate is formed, which shows that there is a presence of this aldehydic group. If the ketone is reacted or is treated with the filling solution, then it will have not given this test. So in the reaction, you will see here, this is a filling solution which is containing this copper 2 positive, 2 plus, and the 5O OH negative. And there is when this aldehyde is reacted with this filling solution. So this there is a formation of this carboxylic acid, you can say carboxylate ion is formed, and this red color, this red precipitate is due to the presence of this copper in this reaction. So this is your two tests that are distinguishing this aldehyde and ketone. So aromatic aldehyde do not respond to failing test. So only the aliphatic aldehydes are responding to the failing test, not the aromatic aldehyde. So an aqueous solution of the compound may be used instead of an alcoholic solution. So in this case, in the failing test, the aqueous solution, the aqueous solution of the compound is used instead of the alcoholic solution. The formic acid also gives this test, but in case of this formic acid, the formic acid that is containing the carboxylic acid, that are also giving this failing test. Next is your toluene test. So in the toluene test is also known as your silver mirror test. So in the toluene test or your silver mirror test, this test is also called the silver mirror test. And toluene reagent consists of silver ammonia complex in ammonia solution. So these tests is also called as a silver mirror test or a toluene test, and in this the toluene reagent is consisting of your silver ammonia complex, and this silver ammonia solution, the silver ammonia solution, this aldehyde is reacting. This aldehyde react with the toluene reagent, and they are giving a gray black precipitate or a silver mirror. So this test is also called the silver mirror test, and in this test, the toluene reagent is consisting of a silver ammonia complex and in ammonia solution. So that is why this test is known as silver mirror test, because in this the silver that is forming a complex with the ammonia in the ammonia solution, and the aldehyde react with the aldehyde is reacting with this toluene reagent, and it is giving a gray or black precipitate or a silver mirror. So in this test, this is the toluene reagent, and in this toluene reagent, This test is also called the silver mirror test, and in this test, the toluene reagent consists of a silver ammonia complex in ammonia solution, and when the aldehyde is reacting with this toluene reagent, then here we are getting the gray or the black precipitate or the silver mirrors we are getting. So always a freshly prepared toluene reagent should be used. So here, in case of when we are doing a toluene reagent, then the reagent that is prepared for the toluene test that should be prepared freshly. So here, apart from aldehyde, some other compounds also respond to toluene test. So here, this aldehyde gives this test, but apart from this aldehyde, other compounds which are containing other functional groups that are also responding to this toluene test. So for the confirmation of aldehyde presence, we have to this when the given substance show a positive when this sample is giving us a positive test for the toluene test, then there is a but if a given compound passes, then this sample should also be passed through this 2,4-dinitrophenyl hydrogen test also. So here from this toluene test, which is also given by the other compound or the other functional group. So for confirming the presence of the aldehyde, we have to also give the 2,4-dinitrophenyl hydrogen test, and if that compound passes through this 2,4-dinitrophenyl hydrogen test, then and it means that it contains your aldehyde group in that. Then the test with chromic acid. So here the test with chromic acid, the aldehyde is reacting with the chromic acid, gives the green to blue precipitate. So here this aldehyde reacts with this chromic acid, and it is giving a blue to green precipitate, green to blue precipitate, and the ketones do not react with chromic acid. Some of the primary and secondary alcohol also give this test, but they do not give diphenyl hydrogen gas. So similarly, in this chromic acid, these aldehydes are reacting with this chromic acid. So chromic acid is the oxidant. So it is oxidizing the aldehyde into the acid. So here it is giving you green to blue precipitate. But the ketones are not reacting with this chromic acid because some of the primary and secondary alcohol, because the primary and secondary alcohols are also giving this chromic acid test. That is why they are oxidized. This primary and secondary alcohols are oxidized and they are formed with aldehydes. And after that, this aldehyde is oxidized in the presence of this formic acid, then there is a formation of this acid. So this if the organic sample gives the positive test against this formic acid, then we have to test again testify this sample with the 2,4-dinitro hydrogen test, and if the sample passes 2,4-dinitrophenyl hydrogen test, that it means that the organic sample is containing the aldehyde in that. These are the four tests that are showing that are distinguishing the aldehyde from the ketone. First is your failing solution, KIF test, failing test, and third is your toluene test, and fourth is your chromic test. Next is your sodium nitroprusside test. So this test is responded by the ketone. So the ketone responded to the sodium nitroprusside test, and the ketone is reacting with the alkali, and there is a formation of a anion. And further, this anion is reacting with the sodium nitroprusside and form a colored complex ion. So here, this ketone is responding to this test, and this ketone is reacting with the alkali form, and there is a formation of this anion, and further it is reacting with the sodium and the sodium nitroprusside, and when it is reacting with the sodium nitroprusside, there is a formation of a colored complex. So here colored complex ion is formed between this ketone and the alkali, and the aldehyde do not respond to this test. So aldehydes are not giving this test So here, if we have to differentiate between the ketone and the aldehyde, then it can be done by these 3-5 tests, because the 4 tests are not given by the ketone, and this the sodium nitroprusside test is not given by the do not responded by this aldehyde. So the aldehyde do not respond to this test. That is why we can differentiate between the aldehyde and the ketone. And in this, the color that appears in the that shows the presence of this ketone is the appearance of the red color. So the so the appearance of the red color shows the presence of this ketone. So the second is your structure and uses of compound. So the structure and uses of compound. So first is your formaldehyde. So the formaldehyde is also known as methanol, and more commonly as formol. And it is an organic compound that is largely used in chemical industry as a precursor in the production of resin, textile, and coating. So here this formaldehyde is known as methanol because it is containing C11O, and it is having we see only one carbon atom, that is the methane, and Al is for the aldehyde group that is attached to this carbon atom. That is why it is known as your methanol, and it is also known as your formol. Formol, formaldehyde, and methanol is the names of this formaldehyde or this structure, and it is an organic compound, and it is used in the and it is largely used in the industry, chemical industry. It is largely used in chemical industry, and for the production of as a precursor. This formaldehyde is used as a precursor in the production of the resins, textiles, and the coating. So the structure of this formaldehyde is this. And the uses of this formaldehyde. So uses of the formaldehyde, that is the CH2O, it is used in the production of resin, principally urea formaldehyde and phenol formaldehyde are used to make pores and molds for fondant. So here these formaldehydes which are used in the production of the resins, and this principally this urea formaldehyde, the urea formaldehyde as well as the phenol formaldehydes which are used to make pores, and molds for fondant. So these are used for making of the molds and cores and molds for the fonderie. So for fonderie uses, these are making this formaldehyde is using this formaldehyde are used in the making of your cores and your folds in case of your fonderie, and it is also used in the production of your resins also. And it is also used in agriculture and medicine, where it is used as a disinfectant, fungicide, fumigant, and preservative. So this formaldehyde is used in agriculture and medicine. So in this, this formaldehyde is used in the aldehyde and your this aldehyde, this formaldehyde is used in your agriculture and medicine, where it is used as a disinfectant, fungicide, and fumigant and preservative. Means it is used as a disinfectant to kill the microorganism or to remove the microorganism. And fungicide means here they are used in killing of the fungus, and fumigant as a smoke. They are used to remove the insects from the plants, and it is also used as a preservative in case of medicines also. So these formaldehydes have many uses as in the production of resins also, and they are used in making of cores and molds for fonderies, and they are also used in agriculture and your medicines, and it is also used as your disinfectant and fungicides fungicides and fumigant and preservatives. So this is your formaldehyde, and formaldehyde is also used to produce a wide array of products, particularly building materials. So this formaldehyde is used to produce products that are used in the building materials also. So it's formal in solution. It's formal in solution is used as antiseptic and disinfectant for most of the fungi and bacteria, and it is also used to preserve biological samples. So it's formalin. So the formalin solution of this formaldehyde, it is used as antiseptic. It is used as antiseptic and your disinfectant, antiseptic and disinfectant, and for most of the fungi and bacteria. So its formalin solution is used as antiseptic and to and disinfectant and for most of the fungus. So in case of fungus and bacteria, where there is a growth of fungus and bacteria, this formalin solution of this formaldehyde is used as your antiseptic as well as a disinfectant, and it is also used to preserve, and it is also used to preserve the biological sample. So here this is used as a preservative for the preservation of the biological samples. So this formaldehyde is used. Next, the compound pentaerythritol produces from formaldehyde and is used in the production of explosives and paint. So this compound that is produces from this formaldehyde, it is used in the production of your explosives and paint. So these these compounds that are used, the compound that is your pentaerythritol that is used in the production of your, that is used, this product is produced from the formaldehyde and this is used in the production of your explosives and paint also. So next is your this paraldehyde. This paraldehyde is also a paraldehyde is a cyclic trimer of acetaldehyde molecule, and it is a derivative of 135 trioxane with a methyl group substituted for a hydrogen atom and in each carbon. So here this paraldehyde is the cyclic trimer. This is the cyclic trimer of this acetaldehyde molecule, and it is a derivative of this 135 trioxane with a methyl group that is substituted for a hydrogen atom in each carbon. So this paraldehyde is the cyclic trimer. So here you can see the structure of this paraldehyde, and this is the cyclic trimer of acetaldehyde. So here you can see the cyclic aldehyde is having the formula that is your CH3CH2OH. So here CH3CH2OH, sorry, CH3C CO. So here this is here this these are the three acetaldehyde which are combined, and there is a formation of this aldehyde molecule. So this is the derivative of your 135 trioxane and with the methyl group. So here you can say that this here you can say that this is the structure of a trioxane also, and where on the 246 position a methyl group is added, or the methyl group is substituted substituted in case of the hydrogen atom in each of the carbon. So a colorless liquid that is sparingly soluble in water and highly soluble in ethanol. So this paraldehyde is a liquid which occur in the state of liquid, and it is and the color of this is colorless, and solubility is that it is sparingly soluble in water and it is highly soluble in ethanol. So this paraldehyde is highly soluble in ethanol, and this paraldehyde slowly oxidizes in air. This paraldehyde is oxidizes in air, and this is turning brown to produce an odor of acetic acid. So this paraldehyde is slowly oxidizes in air and turning this brown turning brown and producing an odor of this paraldehyde in when this is this paraldehyde is oxidizes in air, and it turns into this colorless liquid turns into the brown color, and it produces an odor of your acetic acid, and it also quickly reacts with the most plastics and rubbers. So this paraldehyde is a high reactivity against this plastic and the rubber. So this is the structure of the paraldehyde, or you can say 246 trimethyl S triol. So this is the uses of this paraldehyde, and it was commonly used to induce sleep in sufferers. Means here, if the sufferers who are not having sleep, so these paraldehyde is inducing sleep in them, and in sufferers from delirium tremens, and it has been replaced by other drugs in this regard, and it is the most safest hypnotic and is regularly given at that time in psychiatric hospitals and geriatric wards up to the 1970s. So up to the 1917, this paraldehyde is given as a hypnotic medicines to the psychiatric hospitals and the geriatric wards at the bedtime. And it is also induces sleep in case of in sufferers that are suffering from this delirium tremens. And it is, but after that, it is replaced by the other drugs, and it has been used in the treatment of conversions also. So this paraldehyde is also treating and used in the treatment of your conversions. But today paraldehyde is sometimes used to treat status epilepticus, and unlike diazepam and other benzodiazepine, it does not suppress breathing at therapeutic dose and also is safer. So this paraldehyde is used in the treatment of convulsions, and today they are using in the treatment of this acute epilepticus. And these, unlike diazepam, these diazepams and benzodiazepines are suppressing breathing at therapeutic dose, but this paraldehyde is not suppressing breathing at therapeutic dose and is a safer medicine. So here it's effective in preventing the development of alcohol withdrawal symptoms and on suppressing the syndrome once it develops. It reduces anxiety associated with withdrawal of other drugs such as opiate or barbiturate. So here this paraldehyde is very useful in preventing the development of your alcohol and alcohol withdrawal symptoms. And when we have to withdraw the symptoms of alcohol, or we have to suppress the syndromes of this alcohol once they are developed, and it is also reducing anxiety. Anxiety also reducing, and this reducing anxiety associated with withdrawal of other drugs such as your opiate or barbiturate. And this paraldehyde is also used in controlling seizures that are arising from tetanus or eclampsia. Eclampsia is the condition in which the uh, 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 pregnant women who having the unconscious condition or induced by the poison, as well as in the treatment of status epilepticus. And it is also used to relieving intractable pain which are not responding to opiates, and it does not produces effective analgesia in some anesthetic doses, and may produce excitement or delirium in the presence of pain. This is the structure of your acetone. So acetone is a highly flammable organic compound. This organic solvent has a molecular chemical formula that is your C3H6O, and it is also known as your propanone. And it is found in the exhaust from vehicles, plants, trees, and forest fire. This is up here. This acetone is up here from the, or it is found in the exhaust from the vehicles, plants, trees, and forest air. It is also found in the human body, and it is also found in the human body, usually present in urine and blood. They are usually present in urine and blood. It is colorless and volatile. This acetone is colorless and volatile, and it is miscible. This is miscible in water, ether, ethanol, and has a pungent floral or irritating smell. So this acetone is colorless and volatile, and it is miscible in water, and it is miscible in water and ethers and ethanols, and has a very pungent floral or irritating smell, and it is widely used as an antiseptic and solvent. So this acetone is used as an antiseptic and a solvent for the other uh, compounds. So this is the structure of your acetone, which is also known as propanol. So these are the uses of the acetone. So it is used as a solvent for synthetic fibers and plastic, and it is also used in the prepare metal before painting. And this acetone is used in pharmaceutical industry in some drugs, and it is volatile. And these are hands used in the laboratory to rinse lab glassware. So here these are this is having a property of volatility, and these are used in the laboratory laboratory to rinse the glasswares, and it is also used as a drying agent, and because of its volatility property, and it is also using as a defatting process, and it is used in the cosmetics such as your nail polish remover. So this acetone is used as a cosmetic, as your nail polish remover, and it is also used in the treatment of acne. So this is used in the treatment of your acne also. So this acetone is a solvent that is used for the synthetic fibers and plastic for synthesis, used as solvent for the synthetic fibers and plastic. It is also used to prepare metals before painting. It is used in pharmaceutical industries in some drugs. And because of the volatility property, it is used as a drying agent, and it is also used in the laboratory to rinse lab glasswares. And here it is used in the defitting process also. And this is used as a cosmetic such as your nail polish remover, and it is used in the treatment of acne also. So this is the structure of a benzaldehyde, and it is an organic compound that is consisting of a benzene ring with the formyl substituent. So here the formyl substituent is present on the benzene ring, and it is the simplest aromatic aldehyde and one of the most industrial useful. So it is a colorless liquid with a characteristic almond-like odor, and the primary component of this bitter almond oil benzaldehyde can be extracted from a number of other natural sources. So this benzaldehyde is having a odor which is like a bitter almond oil, and this can be extracted from the natural sources also. And this synthetically, this benzaldehyde is the flavoring agent in imitation almond extract, and it is also used in the flavored cake and other baked food also. So this synthetic benzaldehyde is used as a flavoring agent in the imitation almond extract, and it is also used in the it is also used to flavor cake and other baked goods. The uses of benzaldehyde. So the uses of benzaldehyde is C6H5CHO. So the benzaldehyde is commonly employed to confer almond flavor food and scented products. So this benzaldehyde is commonly employed to confer almond flavor so food and scented products, and this is sometimes used in cosmetic products also. This benzaldehyde is used in the cosmetic products and in industrial setting also. This benzaldehyde is used chiefly as a precursor to other organic compounds, ranging from pharmaceutical to plastic additives. So here, this industrial setting, this benzaldehyde is used as a precursor to other organic compounds, and these are ranging from pharmaceutical to plastic additives. And this benzaldehyde is also a precursor to certain acrylic in dyes, and by idol condensation, benzaldehyde is converted into the derivatives of formaldehyde and styrene, and the synthetic synthesis of mandelic acid start with the addition of hydrocyanic acid to benzaldehyde, and the manufacture of dyes, perfumery, ceramic, and mandelic acid as solvent and flavor. Next is a vanillin. Vanillin is an organic compound which is having a molecular formula C8H8O3, and it is a phenolic aldehyde. It is functional group included your aldehyde, hydroxy, and the ethers, and it is a very primary component of the extract of the vanilla beans, and synthetic vanillin is also used more often than natural vanilla extract as a flavoring agent in food, beverages, and pharmaceuticals. And this vanillin is a member of the class of benzaldehyde carrying methoxy and hydroxy substituent at the position of 3 and 4. And it has a role as a plant metabolite, a flavoring agent, and antioxidant and anti-conversion. So it is a member of phenol, a monomethoxybenzene, and a member of your benzaldehyde because it is containing this ether portion, and this is your ketone, this is your hydroxy, and this is the ketone, this is the aldehyde portion. The uses of vanillin. So the vanillin is well-known food and cosmetic additives and has antioxidant and anti-mutagenic property. It is also suggested to have antifungal activity against major human pathogenic fungi. Although it is not very effective in the study, the antifungal activity of vanillin and particularly vanillin derivatives against the human fungal pathogen Cryptococcus neoformans, the main pathogen of cryptococcal meningitis in immunocompromised patients were investigated, and the largest use of vanillin is as a flavoring, usually in sweets, foods, and ice cream and chocolate industry. Together comprises 75% of the market for vanillin as a flavoring, and with smaller amount it is used in confectioneries as well as in the baked food. It is also used in the fragrance industry, in perfumes, and to mask and present odor of taste in medicines and livestock foders and cleaning products. And it is also used in the flavor industry and is very important to know for many different flavors, especially the creamy profiles such as cream soda. And additionally, vanillin can be used as a general purpose stain for visualizing spot on clear chromatographic plates. This stain yields a range of color for these different components, and vanillin HCl staining can be used to visualize the localization of tannin in cells. Next is the cinnamaldehyde. So cinnamaldehyde is the aldehyde that gives cinnamon its flavor and odor. It occurs naturally in the bark of cinnamon tree and other species of the genus Cinnamomum, like camphor and cassia. These trees are the natural sources of cinnamon and the essential oil of cinnamon bark and is about 90 and it consisting that is 90% of cinnamaldehyde. So this is the structure of cinnamaldehyde, and the uses of formaldehyde is that it is used in the application for flavoring and chewing gums, and ice cream, candies, and beverages. It is also used in some perfumes, artificial sweeteners, specific scents, and almond, apricot, butterscotch, and other aromas. They partially employ the compound for their pleasing smell. And this formaldehyde can be also used as a food additive, and which, in case of powdered beech nut husk aromatized with formaldehyde, can be marketed as powdered cinnamon. So this formaldehyde has been tested as a safe and effective insecticide against mosquito larvae, and this trans formaldehyde works as a potent fumigant and particular repellent for adult mosquitoes. And this formaldehyde is also known as a corrosion inhibitor for steel and other ferrous alloy in corrosive fumes such as hydrochloric acid, and it is believed that it is achieved by polymerization to a protective film on the metal surface, and this formaldehyde has many antimicrobial properties. This is your chlorine hydrate, and this is a geminol diol with the formula. It is this, and it is having the structure where it is a colorless solid, and it is a hypnotic and sedative pharmaceutical drug, and it is used as a laboratory chemical reagent and precursor. And it is used as in the treatment of the short-term treatment of insomnia and as a sedative, and it is used in veterinary medicines also, and it is but it is not considered acceptable with anesthesia or euthanasia for small animals due to adverse effects. And this chlorohydrate is the starting point for the synthesis of many organic compounds, and it is also used in the production of chloral, and it is produced by the distillation of mixture of chlorohydrate and sulfuric acid, which serves as desiccant. Chlorine hydrate is also an ingredient used for Hoyer, a solution amounting medium for microscopic observation of diverse plant types such as bryophyte ferns, seeds, and small arthropod pods. And these include gum arabic and glycerol. And the chloral hydrate is used as an ingredient for the merger, a reagent, and an aqueous solution that is used to identify certain species of fungi. And the main ingredients are potassium iodide and iodine. So this is the hexamine. This is the structure of hexamine. It is also known as methenamine, urotropin, and hexamethylene tetramine. And it is an anti-infective agent, and it having the anti-infective action is derived from the slow release of formaldehyde by hydrolysis at acidic pH of 0.2 molar, and it is a colorless, lustrous crystal or white crystalline powder which is hygroscopic. The uses of this, it is used in the production of liquid or powdery preparation of phenolic resin. It is also used in binders, in clutches and brake lining. It is used as a spray and cream to treatment of odor and excessive cutting, and it is used as a solid fuel preservative, and it is a primary ingredient in making RDX, and it is also used in Rockport, methanamine, silver stain, and used to prevent vulcanized rubber, and corrosive inhibitors for steel. These are the questions. So, which compound is used as explosive? That is your formaldehyde. And which compound odor is similar to acetic acid? That is your paraldehyde, which is used in the cosmetic and nail remover. That is your acetone. And which compound is used in controlled seizures? That is your paraldehyde. It is used to, which is found in the exhaust from vehicles, plant fires. That is your acetone. This solvent is used to rinse wrap glassware. That is your acetone, which is what is used for the treatment of insomnia. That is your chloral hydrate, and it is used to make Melchior reagent. That is your chloral hydrate, and it is used in deflating process. That is your acetone, and which compound is known as formol, that is your formaldehyde. These are the references from where you can discuss, so you can learn this topic. So thank you so much for today's lecture.